Hey everyone, this is Finn, and today we're going to be talking about Git. So, Git is a very important tool for programmers to use, especially when they're collaborating on different projects. And in this context, the key reason why we're going to use Git is, for one, it's a good way of backing up your code, and also you can look back at any state in your code that you choose to document to look back at past things you did that you might have gotten rid of, or to copy those in, or to get ideas from things you deleted. Okay, so that's why we're going to use it. We're now going to talk about exactly what it is. So Git is a version control system which stores and keeps track of, basically, for one project, the versions of the files in that project over time. So, and we use a tool called GitHub to store a Git project on a remote server, and this allows multiple people to collaborate together on a project, because you'll always have the most recent version of the code if you choose to send it. So you have to make each time, but you'll always have the most recent version of the code intended for use, available for use online. And yeah, if you're even if you're the only one working on a project, it can be awesome to keep track of your work and as a backup that to use. And also, if you make a bunch of changes at once and you don't document them, then you risk coming to a point where you're completely confused what's happening, and you forget exactly what you changed. In this case, you can use Git to look back at past your past basically your past versions of the project, and you can revert to these back to where your code worked successfully. Okay, we have to go over some terminology first to be able to talk about Git. So a repository in Git is often referred to as a repo, and it's essentially just a Git project, and it stores your changes over time. So each project you use in Git is going to be a repository. And from projects, in this case, are defined much in the same way that we define them in the Java context. A bunch of related class files which all accomplish some similar task which all come together to accomplish one task. Okay, when we clone a repository from the remote server, we're basically taking that repository and making a copy of all the file contents on your device, so that you can make changes to the repository yourself. Okay, committing basically takes the current snapshot of your code, and it saves the current version of that snapshot. So each time you make a major change, you generally want to commit. And the way you commit is you stage the changes that you'd like to commit. So you would add the files that are relevant to your commit, and then you give them a message that others and you, when you're looking back, can look at your commits and see what does what. So the exact purpose of each commit. So it's important that you provide a good message to describe exactly what you did. So examples would include these ones down here. Actually, one thing to note, this presentation is a bit outdated. The best way to commit is to use your tense in your first thing, not to be past tense, but you want to add the phrase in your head, this commit will, and then add your commit message which describes your changes after it. So in this case, you don't want to say, this commit will implement the command to drive forward. You would say, implement command to drive forward, because you think in your head, this commit will implement the command to drive forward, or document raise arm, or correct bug. So that's the kind of tense you want to use. And yeah, don't forget to use this commit will in your head to make it work. And that's the generally the Git industry standard for this case. Okay, so read over these commit messages and just think in your head, maybe jot down a few notes, whether each one is a good commit message. Okay, and in this case, ignore the tense, because this is an outdated presentation. So the first one, I would say, looks pretty good, because it gives a good description of exactly what you've done, and yeah, and you want commit messages to be concise, because some might say, oh, this is this is too short. It doesn't say exactly where I made the change or all that. But keep in mind that the exact changes you make in the commit can be viewed apart from your message. You just want the message to be a snapshot, an idea of what you've done. Okay, this next one I would say is not a good commit message because line 10 is meaningless. If I want to find where you made a change to the drivetrain code, for example, in one of your methods, I don't care what line 10 is, and I really don't know what line 10 is until I read the code itself. And also, when you look at the snapshot of a commit that tells you all the changes that were made in between the last two commits, it tells you what lines were changed. So this is unnecessary and not very descriptive information to provide. Okay, this next one, you might think that it looks good, but I would say that it's a bit too long. You generally want to keep your commit messages between 50 and 75 characters, and this is just a bit too long, I would say. And it also provides the line numbers, which I said are unnecessary for a commit message. And you could definitely cut this down in certain ways. You wouldn't need to say to method talent in it. If you use the parentheses, it implies it's a method. You would need to say add additional method calls. And then one thing is, because you can choose with each commit what changes you've made that you want to be stored in that commit, you could make two different commits. So you'd make one commit that represents the the changes you made with the new method calls, and then another commit with the documentation you added, for example. That would be how I would approach it if you made two very different changes. So yeah, I would say this is a bad commit message because of the line numbers, and it's just too long overall. It could be split up into multiple. Okay, this last one, yep, I would say yes, it's not too long. It is getting quite close to being too long, but yeah, this is a good commit message. It's exactly what changes you made. You know where. And yeah, the idea of saying where you made the change, you want to say in what class usually, depending on how self-evident it is. But the line number is just unnecessary because line 15 means nothing to you, whereas the class name can be descriptive. Okay, yeah, so we talked about staging changes already. And yeah, so you basically, before you commit, you have to choose what changes you want to commit. So for example, if you've made a bunch of changes, but you have one file that's kind of unrelated and it's not quite done yet, you don't have to commit that file. You can just commit the relevant changes that you've made that are ready to be properly committed as a version of this code. And yeah, we talked about how you can break it up into smaller sections because the ARM and the drivetrain are two completely different things, and they generally wouldn't have to be linked. And then finally, yeah, after you commit, stage changes aren't really changes anymore because they're part of the current and most recent version of the code on your branch. So yeah, once you commit something, a change is no longer a change, and that should make sense. Once you add your current code and make that the most recent version, then yeah, it's not really a change because your code is the code right now, the most updated and recent version. Okay, so one key thing that you should never forget about committing is that everything in commits and staging changes is done locally on your computer and not anywhere else. So if you commit something and do nothing else, then your repository on your computer will have that commit saved and you'll be in good shape. But as I mentioned, we often like to attach or connect our repositories to remote servers, and that gives us a nice backup and also allows other people to view our code and collaborate on it with us. So the way after we've set it up, which is a different thing that is not too relevant for now, after we've got it linked to some remote server, which is also a repository, the way we basically sync up our local repository with the repository on the server is just by pushing. So let's say I made a bunch of commits and I didn't actually send them to the server, to their remote. Now this could be because I was in a place where there was no Wi-Fi connection, or I possibly wanted to make changes to my commits, and because once you push, it's much harder to make changes to your commits than before you pushed. But yeah, so no matter why I didn't push them, let's say I had 10 commits, and they were all unsynced with the remote server, then I need to push to take all the commits that are on my device but have not been updated on the remote server, and this just takes them and pushes it onto the remote server for you. Okay, so yeah, any repository on GitHub at least, which is, as I mentioned, just a remote hosting service for repositories that we use, you can clone, which remember is just taking the repository and duplicating it as a repository on your own computer so you can make changes to it. And it can also be committed to, because remember that is local. But the issue comes in is when you want to push, because if you push to some random repository that you're not meant to push to, then you could risk damaging someone's code base if you aren't authorized to do it. So yeah, that's the idea of open source, is just because something is open source doesn't mean that you have unlimited access to all the code, because that could definitely prove to be something that could be quite dangerous if you could do anything you wanted. And although you could revert, it is possible to force reset past commits, and that could be an example of something dangerous. So you have to be registered in GitHub at least as a collaborator to actually push your repository changes to the remote server. So basically the person who makes the repository has to say, okay, this person is authorized to push their commits to the remote server. Because remember, committing is harmless. It stages the changes that you've made to the repository saved to your computer, and makes that the most recent version of your code on your computer, but does nothing to the remote repository. But yeah, just to be safe, you have to be a collaborator to actually take these commits and push them onto the remote server itself, where anyone can view them, and where they become the most updated version. And pulling is the opposite of pushing. So let's say someone makes changes to the repository and pushes them themselves, then you can pull to take all the commits that you've missed out on while they've been making these changes, and then it'll update your current version of the code to match up with the remote version. So you can view both pushing and pulling as syncing actions that go in two different directions. So if you push, it just takes all the changes that you committed and it pushes it to the remote server. Whereas if you pull, it doesn't have to push anything that you've done. It'll just take all the changes up to now that others have made to the repository in the remote, and update your current repository with those remote changes. And yeah, it's always good to pull whenever you begin making changes, because you can see how if you're making all your changes on an old version of the code, you can risk having what's called a merge conflict, which we'll talk about later. Okay, one thing that is very oversimplified in this presentation, and I don't need to talk about too much for now, is the idea of branching. So a repository can have multiple branches, and basically each branch represents an independent version of the code that is branching off from a set place. So when you make a new repository, you just got the master branch, which is intuitively the main branch you're going to be working with, and that's in general where you want to keep your most stable and updated version of the code that you know is going to work. Whereas, let's say I want to make some insane change that I'm not sure is going to work, and I don't want to accidentally mess up the main branch. Well, then I can branch off, and every time I branch from an existing branch, it basically makes a copy of. It basically takes where you are in that branch, and then branches off again. And so you're starting off at that point, and then you can make any commits you want to that branch, but it won't change the branch that you started from. So yeah, branches can be super nested. So branching is just a way of splitting up your code if you have to make some massive change that you're not sure if it's going to work, or something vital that you don't necessarily want to immediately be part of the main version of the code. You would branch off, and then your commits won't affect the stable or master branch. Okay, merging. So often you'll have multiple people who are making changes at the same time to a repository, and that should make sense. If you have multiple collaborators on a project, then both of them are working at the same time, and because Git requires committing and pushing, it's not going to be what you might expect, like a live code writing where every change, where every character you type is updated on everyone's computer, because remember, you have to stage your changes and commit them and then push them before you can actually have them seen by others. So let's say they both do all their work, and they both try and after they commit, and they both try and push to the remote repository. So in general, there's not much of a problem with this, because Git only actually tracks what files have been changed. So if the two people change completely different files, then it'll be fine. And Git will automatically merge those changes, and you can push without any worry. But where the issue comes in is when two people are working in the same file in around the same place, because you can see how Git won't know which one to choose if they've made different changes to the same line range in a file. So in this case, the way that I recommend you handle it, and the way we'll be handling it in robotics, is to make a new branch for your commits, and then you can push to that branch because no one else will be changing your branch, and then you can submit what's called a pull request to the master branch, and this basically says, okay, my code in this branch is in good shape. I'm ready for it to be merged with master, and then someone can review the pull request, and if there are multiple conflicts, they can choose which should be prioritized. So yeah, a pull request is something you would do in GitHub itself. So you would push to your own branch in your local Git repository, and then in GitHub you would just submit a pull request to the master branch, and it would work out nicely. Alright, finally, using Git. So we talked about GitHub, and as you're watching this video, if you don't already have a GitHub account, you can go to github.com and use your school username to sign up for now. And then from there, we have to use some sort of client to actually interface with Git. And if you've never used Git before, then I would strongly recommend you start off with GitHub Desktop, because it's a very intuitive way of handling things that does not require much complexity, and as long as you understand all the terminology that I've just discussed, I don't worry if you don't quite understand everything. You can ask me any questions, or go and review the video later when you're actually working with Git. But as long as you understand that terminology, then you'll be in good shape to start working with Git. Whereas the most common alternative is a terminal-based use of Git, where you have to use commands every time you want to do something, and that's personally what I like to use. But you have to have some Git experience, and it'll make it harder if you're trying to learn how Git works at the same time as trying to learn the exact syntax of these commands. So I would recommend you use GitHub Desktop, and you can look it up online, and you'll find GitHub Desktop, and then you can link it to your GitHub account that you've signed up for, and then yeah, you're in good shape after that. Okay, so that's it for this video. I'll go over in a future video how to link up your current repository with GitHub Desktop, or no, your current project, how to make it a repository, and then link it up with GitHub so that all your changes can be seen. And yeah, as I mentioned, the reason why we're using Git and GitHub for for these PyBot projects, well, there are multiple reasons. One is the code backup. The other is being able to revert to a working state if you make some radical change that doesn't work out. And then finally, is so that I am able to constantly view your code, and I can suggest any changes that I recommend at any time. So once you make the repository, you can share it with me, and then I'll be able to view your commits that you choose to push. Okay, that's it for this Git video. I'll see you all next time.